Good eve, good afternoon, everyone, and welcome to the lecture. In the previous lecture, I think we had dealt with refraction through a curved surface. Do we remember? We had solved problems of refraction through a curved surface. We had seen the sign convention, what is positive, what is negative, and we solved. We also saw the formula for magnification. Do we remember this formula for magnification? M1V divided by mu1V divided by mu2U. Do we remember this formula?
Yes, sir.
Magnification through a refracting through a curved reflecting surface. That brings us to the topic for today, and the topic for today is known as lenses, or very specifically, we call them thin lenses. What do you mean by thin lenses? Their width are very small. So whenever we talk about lenses, in this particular chapter we will be talking about thin lenses. I hope you know what is a thin lens or what is a lens. Can anyone tell me what is a lens? Quickly, fast. What do you mean by a lens? I guess some of you are wearing lenses as well, so you must be having more idea about lens than myself. Tell me, what is a lens? If I talk about a lens, there are 2 or 3 points that I want to make. Remember, no one is going to ask you what is a lens, but I'm just giving you this information because there can be a question based on this information, and you must remember the important point of that discussion. Anyone who is there, what is a lens, especially to students who are actually wearing them? Yes.
It's a transparent material with two refracting surfaces.
Yes, that is exactly correct. Whenever we talk about lens, there are 2 or 3 points that you must remember. It is a piece of transparent material. Point number one, it is made up of a transparent material. Point number two, it has got two refracting surface. This is point number one. This is point number two. It must have two refracting surface. The third point, as important as the first two, is at least one of them must be curved. So if both of them are flat, plain, it is not a lens. At least one of them must be curved. That is point number three. So glass slab, prisms, everything, they do not fall in the category of lenses. Do we understand this? Everyone
Yes,
understands this? Okay. The fourth point that you must remember is the refractive index of the material must be different than the surrounding. If I have glass inside glass lens inside glass, it will not be a lens, it will just be a glass. If we have water lens inside water or air lens inside air, it will not be a lens, it will be the material itself. So the refractive index of the material of the lens must be different from the lens itself. Do we understand this?
yes, sir.
Okay, now once you know lenses, as soon as I talk about lenses, you must know that there are two types of lenses. Yes or no?
Yes, sir.
What are those two types of lenses? Tell me fatafat.
Convex lens and concave lens.
What are the other name for these two lenses? One is convex, other one is concave. What is the other name for this? Concave and convex. Yes, these convex lenses are known as converging lenses. We know this.
Yes, sir.
And these concave lenses are known as
Diverging lens.
diverging lenses. Yes or no? No, yes. All of us understand these small things about lenses. Yes or no? No, yes.
Yes, sir.
Okay. Now, talking about convex lens, which are converging lenses, we can have different types of these converging lenses. These are the four types that we are normally going to encounter. Do we see this? The first lens in this category is known as, number one, is known as biconvex lens. it is having convex surfaces on both sides. Do we understand this?
Yes, sir.
But the difference is both the surfaces, both the refracting surfaces have different radius of curvature. One is having R1, the other one having R2. Therefore, this is known as biconvex lens. Is it clear? Don't have to draw it, you just have to see it and probably you will understand it. The second type of lens is known as an equiconvex lens. Why it is known as equiconvex? It is convex on both sides and the radius of curvature are also same. We understand this?
Yes, sir.
The third one is known as plano-convex. Why it is known as plano-convex? Because on one side it is plane. Whenever we have a plane, the radius of curvature is taken as infinite. Do we understand this?
Yes, sir.
Plane surface has a radius of curvature which is taken as infinite, and one side we have convex, therefore it is known as plano-convex. We talk about the fourth type of lens, it is known as concavo-convex. One side, if you can see, is concave, and the other side you see is convex. Why it is known as concavo-convex and not convexo-concave is because the convex side is powerful than the concave side. So basically, it will behave as a convex lens. We will understand more about this as we come. This is just to give you a brief introduction about the various types of lenses. We got this? You don't have to draw these, you just have to see it. Are you drawing it? If you want, you can draw it, but that may not serve much purpose. These were the different types of convex lenses. Similarly, on similar grounds, we will have 4 different types of concave lenses as well. The first type would be a biconcave. It is concave on both sides. This one also, both are concave. The second type is equiconvex. Equiconcave, concave on both sides, and the radius are also same. Then we have number 3, plano-concave. One side is plane and the other side is concave. Then we have convexo-concave. One side is concave, the other side is convex. Why we call it convexo-concave and not concavo-convex? Is because it effectively is a concave lens and not a convex one. Do we understand this?
Yes, sir.
Okay, now there is one more way in which we understand what is a concave lens or a convex lens. It is a very, very general way in which I say a convex lens is thicker in the middle and it is thinner at the ends. Do we understand this?
Yes, sir.
So you can also write that one because it might just come as one point. A convex lens is thicker in the middle. Convex lens is thicker in the middle and thinner at ends. If you talk about concave lens, you can say the reverse of it. For a concave lens is thinner in the middle and thicker at ends. Do we understand this?
Yes, sir.
Please note it down. That is a very simple way of understanding a concave and a convex lens. Again, this is just to give you an information about the types of lenses, and there might be a question that comes. Now this is the same thing, just given in a tabular form. You just have to see it. On the left hand side we have convex lenses, on the right hand side we have concave lenses, and you can see the convex lenses are thicker at the middle, whereas the concave ones are thinner at the middle. Do we understand this? We'll get to
Yes, sir.
understand their properties. Don't worry. Remember, in this chapter or whatever chapter we are dealing in optics, everything comes from the definition of things. So we will get into those definitions of those things. There are a couple of things that you must understand definition wise. So we will get into those definitions now. Have you noted it down? Concave and convex lenses.
Yes, sir.
Can I move further ahead?
Yes, sir.
What about the other class? I am not getting any voice from that class. What happened? Everything is okay, beta?
Yes, sir.
Okay. Have you noted it down, beta?
Yes, sir.
Okay. Then the first heading that we are going to write is known as optical center of the lens. Do you know what is an optical center of the lens? Optical center of the lens, and this is the best diagram that can explain this point O. This point O is known as the optical center of the lens. You can call it at the center of the lens. That may not be very correct. This is the optical center of the lens. And what is the property of this optical center? A ray of light which passes through this optical center. See, this is the ray of light which passes through this optical center. Whether you take it as concave lens or whether you take it as convex lens, a ray of light passing through optical center, a ray of light passing through optical center, passing through optical center O will go undeviated. Do we understand this, my dear friends? It will go undeviated. As you can see, it just passes like there is no lens. It just passes straight. Do we understand this?
Yes, sir.
Okay. This is the optical center of the lens. Now, just some things that you got to see here in this diagram. If I call this surfaces as number 1 because a lens has two refracting surface. If I call this surface as number 1, this surface becomes number 2. Do we understand this?
Yes, sir.
Here, this surface is number 1 and this surface is number 2. Do we understand this? Yes or no?
Yes, sir.
Now, every refracting surface which is curved is always a part of a sphere. Did I tell you that? Yes or no? Did I tell you that
Yes, sir.
every curved surface is a part of a sphere? This is sphere number 1, of which the spherical surface is part. This is sphere number 2 of the. This is the sphere from which the second spherical surface has been taken out. Do we understand this?
Yes, sir.
Both these
Yes,
spheres
sir.
have one center each, C1 and C2. Do you see the center C1 and C2? Here also C1 and C2. These are the center of curvatures of the spherical surface. Do we understand this?
Yes, sir.
The line joining these two points is known as principal axis.
Principal axis.
Spelling is wrong. The spelling should be Principal. Principal axis. Principal axis is a line joining the two center of curvatures. Do we understand this?
Yes,
Yes,
sir.
sir.
Then there is a line known as the optical axis. This optical axis is perpendicular to your principal axis. Do you see this?
Yes, sir.
And it passes through the optical center. So there are 3 definitions here, or you can say 4 or 5, depending on if you call C as the definition or not. Do you see C? C1 and C2 are what? C1 and C2 are
Center of curve.
center of curvatures. C1 and C2 are center of curvatures of surface 1 and surface 2. Principal axis. Principal axis is a line joining joining C1 and C2. Optical axis is perpendicular to principal axis, passing through O. Do we understand this?
Yes, sir.
Is this clear to everyone in the class?
Yes, sir.
Yes, sir.
Okay, I'll give you 2 minutes to note it down. Note it down. Everything in this chapter is all about definitions. Note it down.
Done, sir.
The other class, note it down, bacha. Once you are done, please let me know. Both the class together. Unity is strength. Strength is unity. Unity is strength. The first class is united. I guess they have read the topic before. Is that so, beta? Girls? These girls are super smart. They read the topic beforehand. And that is why they do all the stuff before. The other class is not so smart. They follow me. So what I do, they only do that. And they don't want to do anything extra. I don't know which strategy is correct. But as long as you are studying, whether you are studying in the forward, in the future, or in the past, or with me, as long as you are studying, that strategy is good. Shall we move ahead in life? Life has to move on.
Yes, sir.
The other class, I'm not getting much of your conversations.
Completed, sir.
Completed, sir. The next heading is principal focus. Can anyone tell me? The girls can definitely tell me because I think I've read it. Principal focus. What is principal focus? Yes. For a lens, we are talking about. What is the principal focus for a lens? Yes, fatafat, tell me. Huh? Every lens says how many principal focus. Now, as soon as you hear the word focus or principal focus, you can take yourself back to your mirror. Every mirror had a focus. Yes or no?
Yes, sir.
What was the focus of the mirror? How did I define the focus of the mirror? If you remember that definition will, yes, yes.
The meeting point of reflected rays.
Okay, you don't remember it exactly, but you remember it somehow. You have to remember it exactly. Now, whenever we talk about focus of a lens, there are two principal focus. The first one is known as the first principal focus, and the second one is known as second principal focus. So there is no, this is a very simple thing. The first one is known as the first principal focus. The second one is known as the second principal focus. Now, whenever we are talking about focus of a lens in general, if you are wearing a convex lens and I ask you what is the focal length, from focus comes focal length. We are basically, whenever we are talking about focus, we are basically talking about which focus? We are basically talking about second principal focus. Now, if there are two principal focus, there would be two ways of defining it. This one is the first principal focus. And what is the first principal focus? This might remind you of what you studied for your mirror. This is exactly how the mirror focus was defined. Ray of light which passes through the focus. After passing through the focus, it becomes parallel. Do we understand this?
Yes,
A ray
sir.
of light which passes through the focus after refraction becomes parallel to the focus in case of become parallel to the principal axis in case of convex lens. In case of concave lens, ray of light which is appearing to go towards focus, after refraction they become parallel. This focus, the spelling is wrong, this focus is known as the first principal focus. The first principal focus is the point on the principal axis. If you place an object there, the image will be formed at infinity. Do we understand this? If an object is placed at the first principal focus, after refraction, the rays of light are going to get parallel, and therefore the image is formed at infinity. Do we understand this? Yes or no?
Yes,
Yes,
sir.
sir.
Anyone understand this? This is, my
Yes,
dear
sir.
friend, the first principal focus. You may draw a diagram. If you understand it, you don't have to draw it. If this is the first principal focus, my dear friend, what would be the second principal focus? If that one was the first, how will I define the second? Yes, tell me. First principal focus is the point where you place an object, the ray goes parallel after refraction. Image is formed at infinity. How will I define the second principal focus? Yes. I do the reverse of it. If rays of light are coming parallel to the principal axis, after refraction, they will converge to a point on the principal axis in case of convex lens. In case of concave lens, they will appear to come from one point on the principal axis. That point is known as the second principal. Spelling is wrong. Second principal focus. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
Do you understand the difference between first and second? In case of mirror, if we only have one focus, so ray of light which passes through focus after reflection becomes parallel. A ray of light which is parallel passes through the focus. But here, there is no reflection, there is refraction. This is one side and the other side. So we have one focus on the other side and one focus on the other side. Do we understand this? It has gone above our head saying bye bye, I'm going, don't worry. And whenever in general we are talking about focus of a lens, we are talking about which focus, my dear friends? We are always talking about which
Second
one?
principal focus.
Second principal focus. So this is all you need to know about the first and the second principal focus. I'll give you 1 minute. Have you drawn the, are you drawing it or you are just writing it?
Both, sir.
Both, sir. So I'll give you a minute, sir. Do it
Done,
fast,
sir.
sir. Done, sir. What about the other class, sir? Other class is still wondering what to do, what not to do. Yes or no? No, yes. Huh? Done, 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 done.
Completed, sir.
Okay. Since we have done focus, the other thing would be the focal length. Yes or no? Point number 3, wrong color. I don't use wrong color. Point number 3, the third thing will be focal length. How many focal length will a lens have? 1 or 2?
2, sir.
First principal focal length and the second principal focal length. Yes or no?
Yes, sir.
How will you get the focal length? So you take the optical center and you find the distance of the focus from the optical center. That will be known as your focal length. So if you find out the distance of the second focus from the optical center, this will be known as the second principal focal length. Do we understand this? F2 is the second principal focal length. Distance of the second focus, second principal focus from the center of the lens or the optical center. Do we understand this? And will give me more confidence that we understand this. Boys, I hope you are not sleeping in the class. Yes or no? F1 and F2. Two focal lengths. Whenever we talk about the focal length of a lens, which focal length are we talking about?
Second principal focal length.
Second principal focal length. The distance of the first focus from the center of the lens will be known as the first principal focal length. We normally do not talk about it, but it's my humble duty to tell you, to show you, so you can draw it in the diagram. This is the optical center, F1, F2. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Okay. Now is the time that you write. Have you written this?
Yes, sir.
The other class.
Yes, sir. Completed.
Well done. Now the other class has also uh, come up. The first point that you must remember is second principal focus is is known as the second principal focus is the principal focus. Whenever we talk about the focus of the lens, we are talking about the second principal focus. Will you remember this? Or the focal length for that matter. Point number 2, if, and these points are potential questions that have come in your exam, if medium on both sides of the lens is same, then f1 in magnitude is equal to f2 in magnitude. Why I'm writing magnitude? Because we have a sign convention. Because we have a sign convention. Because we have a sign convention, and according to that sign convention, one direction is positive and the other direction is negative, and therefore one focal length will be positive and the other focal length will be negative. Do we understand this? We will get through those sign convention, don't worry. I'm using the magnitude sign just because of that sign convention. Is it okay? So if we have air on both sides, or if we have water on both sides, or any other liquid on both sides, the first principal focal length and the second principal focal length will always come to be same. Yes or no?
Yes, sir.
I hope we are noting it down.
Yes, sir.
But what will happen if the medium on both sides is not same? This question has come many times in your exam. What will happen if the medium on both sides is not same? For example, it may be like this. Nang, 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 nang. On one side, my dear friends, we have mu1, and on the other side, we have taken the example of a convex lens. On one side, we have mu1 and the other side, we have mu2. In that case, what will happen? Remember, my dear friends, your f1 was here, yes or no?
Yes, sir.
For convex lens. And your f2 was here, yes or no?
Yes, sir.
What is the effect of the difference in medium? So if this happens, then you will have this ratio f1 by f2 will be equal to mu1 by mu2. Remember this, keep this always with you. Okay, we are noting down important notes. Yes or no? No, yes.
Yes, sir.
Yes, sir.
Okay, what is the next important note? Next important note, focal length for a convex lens, the focal length, which is f2, is always going to come as positive. I will show you that sign convention, don't worry. For a convex lens, the focal length is going to become positive. For a concave lens, the focal length is going to become,
Negative.
because you will say, sir, concave lens also has one focal length which is positive. But whenever we talk about focal length, my dear friends, we are talking about which focal length?
Second principal focal length.
Second principal focal length. I hope everyone gets this. What if the surface is plane? For a plane surface, glass slab, what is the focal length of a glass slab? Infinite. Do we understand this? It's not zero, it's infinite. Yes or no? We understand this? Let me know when you are done. We'll move on to the next point.
Done, sir.
Are they so quick? Even I can't do it so quick. Okay, well done. What about the other class?
Completed, sir.
Wow, and now we are competing. The next thing is power of a lens. Power of a lens. Whenever we talk about power of a lens, the SI unit is diopter D. Yes or no?
Yes, sir.
Power of a lens is 1 by f of the lens. If the focal length is in meters, it is 1 by f in meters. If it is in centimeters, it is 100 by focal length in centimeters. Then you will get the power in diopters. Do we understand this?
Yes, sir.
You must be wearing lenses, so you must know. Let's write it as FL, PL, power of the lens. What is the power of a mirror, PM? The formula for power of a mirror is minus 1 by f if it is in meters, or it is minus 100 by f if it is in centimeters. Then we are going to get the power in diopters. Do you understand this? Do you remember this?
Yes, sir.
Now, remember one important point about power. Power for converging, whether it is a lens or a mirror, if it is converging, the power is positive. That means power for a convex lens or a concave mirror is going to come positive. Do we understand this?
Yes, sir.
Because convex lens is converging and concave mirror is converging. What can you say about power for diverging instruments? Power for diverging instruments, whether it is a lens or whether it's a mirror, power for diverging thing will always come as
Negative.
negative. So diverging the lens is concave, in diverging the mirror is convex. Do we understand this?
Yes, sir.
And as you can see, it is quite clear from the formula for power. In the formula for power for a lens, it is 1 by f. So for a concave, it is negative. For a convex, it is positive. The formula of power for a mirror is minus 1 by f. So for a concave, it is positive. For a convex, it is negative. Do we understand this? Yes or no? No or yes?
Yes, sir.
Yes, sir.
Okay, I'll give you 1 minute to note it down.
Done, sir.
Everyone has noted it down? Everyone has noted it down, bacha? Can I move ahead?
Completed, sir.
Okay, the next and the last heading definition is known as the aperture of the lens. It's known as the aperture of the lens. Now, what do you mean by this aperture of the lens? You look at this. This will be known as the diameter of the lens. Yes or no? Do we understand this?
Yes, sir.
This diameter is known as the aperture of the lens. The effective diameter of the lens D, this D is known as the aperture of the lens. Now, why it is important to remember this? Because sometimes you are asked question where you are going to cover half of the lens or cover it with some other material. What? And then they will ask you what will happen to the image. Remember, the intensity of image is directly proportional to your diameter or aperture square. So if your diameter becomes half, the intensity of the image will become 1 by 4. Do we understand this?
Yes, sir.
Yes, sir.
Okay. That is all about the definition of different things that we are supposed to know. Have you noted it down, my dear friends?
Yes, sir.
Then the next thing, we'll just go through it quickly because I think you already know it, but I will just go through it quickly, is known as the sign convention. We are going to go through this mirror formula, the lens formula, and we will be going through the sign convention, whether it is a concave lens or whether it's a convex lens. The sign convention is going to remain same. Yes or no? No, yes.
Yes,
Sign
sir.
Yes,
convention
sir.
is not going to be different. So, what is the first thing that you must remember about sign convention? All distances are measured from
Pole.
here. There is no pole.
Optic center.
All distances will be measured from the optical center. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
Now, my dear friends, if the object is here, rays will be coming in this direction. Which direction is taken as positive? Direction of which ray?
Incident ray.
Direction of incident ray is positive. So, if the object is placed on the left hand side, this direction, so everything on the right of optical center will be positive, everything on the left of the optical center will be negative. Yes or no? No, yes.
Yes, sir.
But if the
Yes, sir.
object is placed here, my dear friends, and remember there could be cases in case of lenses when the object can be placed on the other side, the incident ray would be coming from this side. In this case, this side. In this case, this direction would become positive. Do we understand this?
Yes, sir.
Because lens ray can come from both sides. Mirror, it was only from one side. Yes or no?
Yes,
But
sir.
for a lens, it can come from this side, it can come from this side. Therefore, you must be careful. Will you be careful, my dear friends? Ray can come or light can come from both sides. Then, what next? One thing is fixed. Distance above O, distance above O will be taken as positive. Do we understand this?
Yes, sir.
Yes, sir.
Okay, now let us apply this sign convention on this diagram. The distance of the object is known as U. Will U be positive or will U be negative here in this case that I've drawn?
Negative.
Why it is negative? Object O is here, optical center is here. Oh, both are called as O. So let me name this as C center so that it looks different. Optical center is here, object is O, light is coming in this direction and I'm measuring distance in this direction. Yes or no? So this
Yes,
U will
sir.
turn out to be negative. Do we understand this?
Yes, sir.
If my image is formed here, the distance of the image from the optical center is known as V. Can you tell me what is the sign of V? Fatafat, we don't have time.
Positive. Sir.
It is going to be positive. Yes or no?
Yes, sir.
Yes, sir.
What type of lens is this?
Biconvex.
What will be the focal length of this lens? Will it be positive or will it be negative? Remember, the focal length of a convex lens, unless and until you change the medium, it will always remain positive. Now a question can come, sir, what will happen if instead of object kept here, I keep the object here? Will the focal length become negative? No. The focal length or the lens does not change if I keep the object here or if I keep the object on the other side. A convex lens always remains convex. A concave lens always remains concave. So no matter what your sign convention is, a convex lens will always have positive focal length. Do we understand this?
Yes, sir.
Yes,
The
sir.
focal length can only change if I change the radius or if I change the medium. If I change the medium, then a lot of things will happen that we'll see in the next class. Unless we change the medium, the focal length remains same whether you put the object here or you put the object here. The sign also does not change. Will you remember this?
Yes, sir.
Yes, sir.
Okay, so this was all about The sign convention for the lens, I've done it for a convex lens. The same thing is true for a concave lens. The focal length of a concave lens always remains negative unless and until you change the medium surrounding it. Have you written it down? Yes or no? No or yes?
Yes, sir.
Everyone?
Yes, sir.
Okay, then we will see some ray diagrams for image formation by a convex and concave lens. Do we remember how many different positions we had seen the image formation for a concave mirror? Do you remember concave mirror? We had seen the image formation by 6. Now, whatever we have done for concave mirror, remember it was converging mirror. The same thing we'll have to do for
Diverging.
the same thing we have to do for convex lens, because convex lens is always converging. Do we understand this?
Yes, sir.
So how many different positions are we going to see the image formation for a convex lens?
Two, sir.
Convex lens. 6 positions we have to see. Do we understand this?
Yes, sir.
What was the first position that we saw for concave mirror? Where was the object? And where was the image? Where was the object and where was the image? The first case for concave mirror. Where did I first place the object?
Infinity, sir.
The object was at infinity. Yes or no?
Sir, can you please share the slide?
Where the object was for concave mirror? Where was that? It was at infinity. Yes or no?
Yes, sir.
Where was the image formed? It was formed at the
Focus and center.
Focus.
same thing happens here. The first case, when the object is placed at infinity, image is formed at focus. It is real, it is inverted, and it is very small in size. Same thing that happened for concave mirror, same thing happens for convex lens. Do we understand it, my kids?
Yes, sir.
That's why I was not showing it to you, so that you can correlate it with the concave lens. For the concave mirror. This is the first position of object when the object was placed at infinity. Do you remember what was the second position, my dear friends?
Between infinity and center of curvature.
Between infinity and center of curvature. Here there is no center of curvature. We call it 2f. There was 2f, na? R was 2f, na?
Yes, sir.
So we call it 2f. So now the second position is between infinity and 2f. No one is going to ask you to draw the ray diagram. This is just for your academic purpose. So when the object is placed between infinity and 2f, the image formed is between f and 2f. Do you remember? Between C and f. The
Yes,
image is
sir.
inverted. It is real and it is smaller in size. That is, magnification is less than 1. Do we remember it? So if I remember everything from the concave mirror, same thing is applicable here. The only thing is, for concave mirror, image was coming on the same side. For this convex lens, image is going on the other side. Do we understand this?
Yes, sir.
Yes, sir.
Have you noted down these two things?
Yes, sir.
What would be the third position?
Object placed at 2f.
Object placed at 2f. And what will happen to this object what is placed at 2f?
Image will also form at 2f.
What will be the size of the image?
Same size.
Will it be real or will it be virtual?
Real, sir.
So same thing happening. Object is placed at 2f. Image is real, 2f, inverted, equal in size. The only difference is in a mirror, it was on the same side. Here, it is on the opposite side. Do we understand this? Yes or no?
Yes, sir.
What about the next case?
Object placed between 2F and F.
Object placed between 2f and f. What was happening in that case? The image was formed beyond 2f. Yes or no? Beyond center of curvature. It was inverted. It was enlarged. Magnification was greater than 1. Same thing happening here. The only thing is the image is coming on the other side. Do we understand this? Yes or no? No or yes?
Yes, sir.
What was position number 5?
Object placed at F.
Object placed at f. Which f will I place the object now? Which f?
Second principal F.
First principal focus. If I place the object at this point on this focus, the image will be formed at infinity. Do we understand this?
Yes, sir.
Or if I place the object on this side, on this focus, then this will become the first principal focus. Image is still be formed at infinity. Do we understand this?
Yes, sir.
So it is same whatever way you look at it. Do we understand this?
Yes, sir.
What is the last thing that you must remember? The last position, and that is a very important position because it is different from all of the positions. Object is placed
between
F and O. Image in only this case is virtual, it is erect, and it is enlarged. We will discuss this and the concave lens in detail in the next class. We will also write their characteristics, what thing you have to remember and what thing you will have to recollect. So just draw the diagram. You already have the diagram. I'll see you in the next class. If you have any doubts, please come up. Else it's a wrap from my end. Have you understood all the 5, 6 positions? Yes or no?
Yes, sir.
Yes, sir.
Same as concave lens. Okay. And I'll see you in the next class. Take care. Have a nice day. God bless you all.